So before we go into detail of 4.3, we will go back and again, actually we'll see the material very similar to 4.1 and 4.2. But 4.3, we will begin with conditional probability and multiplication rule. So reminder, 4.2 was the addition rule, right? The addition rule. Oh, one thing I forgot to mention in 4.2, well, when we get to that problem, I mentioned it, is the same concept. But anyway, let's take a look at the conditional probability. So what is a conditional probability? A conditional probability is just basically is an event B, right? We say that a conditional probability is an event B given that A is already a curve. Okay, so a conditional probability is just like its name, is pretty much some condition has to met before the event B can happen. Okay, and we denote a conditional probability with this vertical line, which is basically whenever you see this vertical line, you would say that the probability of B, the probability of something happen given A have already occurred, A have already happened. Okay, and to find this conditional probability, which is again, like I mentioned, all this thing here, is we plug into, or this is our formula for conditional probability, is probability of A and B, which is the intersection. What is A and B overlap? Divided probability of A by itself. Okay, so again, a conditional probability is again, like I mentioned, is probability of B given A have already happened, right? So again, that's what conditional probability is. And one thing I want to point out, or as you will see when we attack or go over this problem, whenever a conditional probability, we will not deal with the grand total, the overall total. Okay, and like I mentioned yesterday, like I mentioned in 4.1 and 4.2, in order for you to find a probability, the most important thing that you need to do, or you need to have, is you need to have a total. So one thing about conditional probability, as you will see, is conditional probability, a total will change. There are something different in terms that the total now no longer every single item we have. The total is a new total, which is a new condition. This condition have to met first. Okay, so again, notice that if we have P of A, if the probability of A is equal to 0, then we cannot find that probability, because again, the 0 on the denominator is undefined. Okay, so given that, and all this thing is just basically the same. All this thing is basically the same. Just tell you that a conditional probability is basically the intersection of A and B, meaning what A and B share or have in common, right? Divided by just the total of A by itself. Okay, so looking at this thing here, let's take a look at our example, right? Take a look at our example, and then hopefully with the example, it's easy for you guys to recognize the difference between conditional probability versus the mutually exclusive and the simple probability. So this is what they have, is a department store have 385 stores all over the United States. The following table classified by a population size, location, and the present number of stores in each category, right? So again, a store is to be selected at a random from this 385 to test the market for a new product, right? So again, this is our information here. This is what we have is, again, the population of the city is either under 50,000 or between 50,000 and 500,000 or over 500,000. And again, one thing is, ladies and gentlemen, this problem is the same problem that you will see on your Connect map. And again, the number will be different because I think on your Connect map, the number is bigger. And I just make it number smaller for me. And as you can see, we have a region, we have a northeast region, southeast region, southwest, and northwest, right? So this is your region, and at each region, this is the number of store, right? The number of store in a northwest region in the city under 50,000 people is 25, right? And so on and so forth. And one thing is on your, I think on your Connect Math, you don't have the total. So you have to find your total by yourself, okay? We know that the grand total is 385. And again, if you add all this number across, you have 69. If you add all this number across, you have 187, so on and so forth. If you add vertically down here, then you have those, right? So let's take a look at the question, which is, again, you say, wait a minute, Mr. Tran, this is not the new material problem. Yes, it's not. This is your yesterday material, which is, again, what is the probability that a store is located in a southwest region, right? So again, this is the problem. The problem is I go into this data, I pick out one store, right? We select a store at random, right? What is the probability of this store located in the southwest region, which is, as you can see, they don't have the word or, so we know that it's not a mutually or not mutually exclusive event, right? This is just a simple event, right? Which is, again, how do we find a simple event? Which is to find the probability, like always, we need to know the total, which is, in this case, we know that there are 385 stores. And again, we know that to do the probability, we need to know what we're looking for, which is, in this case, we're looking for the southwest region, which is the southwest region have 110 divided by the total, which is 385, which give us 0.286. Okay, it is 285 something. I rounded to 2.86. Okay, so again, looking at this thing here, that is what we did yesterday, right? This is what we did in terms of the simple event. And now similarly, same idea, right? Which is, what is the population, right? If we select what is the probability that a store is located in a city with a population under 50,000 people, right? So looking at this thing here, this is my under 50,000 people city, right? Again, it doesn't matter if it's in southwest, not southeast, northwest, northeast. As long as it's under 50,000 people, this is what I have, right? And again, once we have this thing here, which is, again, same thing go, what are we looking for? We're looking for the city under 50,000 people, which is 69 of them, over the total, which is, again, you have this. Which is, this thing is what we did yesterday, and vice versa. The last item we have is, again, similarly, what is the probability that a store is located in the southwest region and under 50,000 in population, right? So again, looking at this thing here, the word and, as you will see, the word and here is basically, again, what is the city in southwest and also under the 50,000 mark, right? Which is, again, do you agree that there's only 11, specifically, there's only 11 city that is located in the southwest region and also have under 50,000 population, right? Which is, looking at this thing here, all we do is we take this item, which is, again, we take 11 divided by 385, which give us 0.29. So again, question with this three item here that we have in terms of the material from yesterday. So now, one thing I forgot to mention about material from yesterday is, everybody see right here, this item right here, 0.029. So one thing is this author, or later on you will see that they mentioned about the unusual probability. So when is our probability unusual? If there's a cutoff, this author cutoff is if your probability, or later on if you see that your percentage is under 5%. If it's 5% or below, if it's 0.05, if your probability is 0.05, we say that this is unusual. It's basically tell you that it's very rare that this thing will come out. It will come out, right? As long as there's a probability, it will come out. It's just that it will be very rare. So because it's rare, because of the small probability, we say it's rarely will come out. And if it's rarely come out, we just say it's an unusual. No, later on you will see that it's unusual data, or unusual, in this case, unusual probability. So the cutoff of unusual is basically below 5% or 0.05. Okay, so if on your homework, if part C, they ask you, is this unusual or usual? You say that this is an unusual. Okay. Question. Question here. So again, if you look at this thing here, you say, wait a minute, Mr. Strand, we haven't done anything new. And yes, we haven't done anything new. This is your new product. The previous 3 problem is what we did yesterday. It's just that I forgot to mention about the unusual item. So now looking at this thing here, let's take a look at this item, which is what is the probability that a store is located in the Southwest region, given that the store is in a city with a population under 50,000, right? So if you look at this thing here, you say, ooh, something new, right? There's something new. We have 2 items. We have a Southwest and we have under the 50. But if you were to do this on your homework, on your test, or on your exam, midterm and your final exam, the first thing is, again, we need to find the probability. That's what they ask you, is find the probability. The second thing you have to recognize is, oh, we have the word given, right? Remember in 4.2, we have the word or. And the word or tell us that, well, we have to ask ourselves, the word or is it mutually or not mutually exclusive, right? But now the new word or the new keyword come in is now we have the word given. So if you see the word given, which is, again, this is reminder that this is our formula for the word given, which is the probability of the first event given the second event already occurred, or the probability of the second event given the first event already occurred, right? So probability of B, vertical line A, which is probability of B given A. So if you were to do this thing here, which is, again, the question we'll ask you is, what is the probability of the location is at Southwest, given that is under 50,000. And if you recall on the previous slide, if you recall on the previous problem, we did this, which is, again, what is probability of A and B? Well, A and B, which is the Southwest and under 50, which is, we did this, which is 11 divided by, which is, again, the and, which is the intersection divided by 380, right? And again, we did find the probability of under 50,000, right? We did that, which is, what is under 50,000, which is, again, under 50,000, which is 69 divided by 385. So given that, we have the 2 number we have in terms that the N is this item here, and the A, the probability of A is this item here, which is, again, all we need to do is we can plug in, which is, again, Southwest, given that is under 50,000. Do you agree that where they intersect, which is 11 over 385 divided by 69 over 385, right? We have the and we have the under 50,000. All we need to do is divide them. And again, how do we divide complex fraction? To divide complex fraction, we need to take the reciprocal and multiply, which is, reminder, if you multiply the fraction, which is 385 and 385 disappear, which is, as you can see, this is what we have. The probability of a restaurant located, or not a restaurant, the store located in Southwest region, given that the store is in the city of population under 50,000, is 11 over 69. So one thing like I mentioned before, to you guys is the word given, something had to happen first, okay? Meaning the total, we will no longer compare to the grand total, the 385 store. This is what the conditional property is given the store is under the the population under 50,000, meaning, again, the question is, how many store is under the 50,000 in population, which is, everybody see that the total is 69. So one way is, instead of doing all of this formula, this is what I tell my student, or this is what I tell you guys, is anything after the word given is your new denominator, ladies and gentlemen. Anything follow the word given here. Everybody see that given that a store is is under 50,000, which is, again, that is your new denominator. That is what you need to take out. That's the condition you need to take out. Now, everybody see that the condition have to first met is after the word given, right? So the condition is they have to be under the population under 50,000. Now, out of the 69 store, I only focus on this 69 store. If it's more than 50,000, I don't care, right? I need to have the store that qualify for this condition, which is under the population under 50,000, which is there are 69 of them. Out of the 69, how many of them are located in the Southwest region? Everybody see that the Southwest region is actually the second event, right? The second item. The first item followed by the word given. So everybody see that instead of doing all of this complex number, this is what you need to ask yourself is what is followed the word given? Take that total out. Take that condition, take that requirement out first. Out of those requirements, how many fit the first description? Okay, so let's take a look at another one, which is, again, very similar, right? Very similar. What is the probability? What is the probability that a store is located in the city with a population under 50,000, given that a store is in Southwest? So looking at this thing here, like I mentioned on your test, you have to recognize that this is the word given, which is, this is a conditional probability, which is now we are no longer compared to every single store. We only compare to the, again, looking at this thing here, how many store is in the Southwest region, right? How many stores in the Southwest region, which is everybody see that anything follow the word given, which is the Southwest region. Do you agree that we have 110 store in the Southwest region? As long as it's not in the Southwest region, we don't care. The first requirement is the store have to be in the Southwest region, given the store is in the Southwest region. And now, out of this 110 store, how many of them are under the population under 50,000, which is same number, which is, again, basically what they have in common. Where does the two intersect? Over the first item or over the given item, okay? And again, if, you know, I don't have, if you were into class, if we were to be in class, as you can see, if you look at this vertical line, imagine this vertical line is the fraction. The vertical line here is like a fraction. Anything, if you flip it clockwise, you can see that the Southwest, which is the one, you know, whatever the second portion, whatever the second half, that is your new denominator. That is your new total. Okay. So again, looking at this thing here, everybody see, which is, again, first of all, question with D or question with E. And again, the two answer, as you can see, if you look at this thing here, the two description, if you just look at it, the two description is the same. It's just the order of how they state it, right? Both of them are Southwest and both of them are under the population under 50,000, right? So looking at this thing here, it's just that you have to, this is the main thing. The main thing is you have to know what is the condition, what is the first requirement. And the first requirement is followed by the word given. Question with D or E here.
Does that mean any word before given is going to be your numerator?
Well, the joy of the two is your numerator. The joy of the two, or the overlap of the two, is your denominator. The Southwest and also in under the 50,000 is your numerator. It's not just the Southwest, right? It's not just the Southwest on the numerator, because again, Southwest is bigger than the under the 50,000. The 11, you see where the 11 is at. So it's not that the first thing is on your numerator, it's the and of the two, right? The two is your numerator.
Okay.
Is that making sense?
Not really, but I think if I keep watching, it'll catch on.
So if you look at this formula right here, the formula right here is probability of A and B, right? So the two events have to be on the numerator. It's not just one single event on the denominator. It's the specific case, which is the first thing and also the second thing on the numerator. Is
First and the second, is it the first and the second, they're multiplied
no,
or added?
it's what they have overlap, what they have in common. If you remember